Now it's starting.
No, wait. Dominic started it. Now you lost. That fast.
So then who's the tutor?
If it's Dominic and then.
Okay, well this week we're going to be talking about chapter 15, which is all about inheritance. Our assignment for the week is going to be deriving a new class called Administrator from the Salaried Employee class.
It's on the table.
And
It's starting now.
writing a driver program that exercises the various functions. That's project number 1 for
Starting now.
chapter 15. So you can look at that. All that starts on page 857. So there's going to be, we're going to derive that administrative class from the salaried employee class, which is in this chapter. And then they've got the various variables that need to go into it, the protected member variable, and so forth. So we should talk about the inheritance information that we need to know in order to be able to do that. Inheritance is just the way a new class is created from another class. So the original class is called the base class. The new class is called the derived class. Also, we can call the old class the parent class and the new class child class. Different people use different terminology for that.
You guys, it's starting now.
Okay, so if we're talking about making a record-keeping program. We'll have records for salaried employees and hourly employees, and there's a lot of things those two different types have in common. So in display 15.1, we have the interface for the base employee class. So that's page 814. The private member variables are name, social security number, and net pay. And then it's got several member functions, get name, get social security number, get net pay, and then set. So we have accessors and mutators, and there's a print check function that allows it to output a sample check for that employee. Now, any new class that we make derived from the employee class will inherit everything that class has. So anything that class has will be inherited by any new class that we come up with. Page 815 has the implementation for that. So we've got the constructors, the accessors, the mutators, and then they've highlighted the print check function that does something a little different.
So, whereas it's a derived class,
Starting now. It's starting
there
now. I
any
said it's starting now.
declaration or anything that needs to be done, or is it just?
Yeah, well, they're going to show us how to derive a class here in a minute. So, in fact, the very next display is for a derived class. But you'll notice the print check function for the employee class just says this is an error, because they don't expect you to ever use an employee variable by itself. So they expect you to always use one of the classes that are derived from employee rather than the employee class. So the next display is for hourly employee, and that's derived from employee, and you'll see on line 10, display 15.3, it says class hourly employee : public employee. That's the way we derive a class from a class. So hourly employee is derived from the employee class. How much do you need? And so then the rest of that interface is things that the hourly employee has that are going to be different from the underlying employee class. And it even says only list the declaration of an inherited member function if you want to change the definition of that function.
Have new shoes or go to the store and get a toy?
Go to the store and get a toy.
And you'll also see they put wage rate and hours. Those are the new variables that belong to hourly employee
Loud and clear.
that we didn't have for employee.
No.
Okay?
No.
And then they have the interface for the salaried employee class. So hourly employee has wage rate and hours, and then the salaried employee has a salary variable. And again, they've defined print check because that's going to be different for a salaried employee than it was for an hourly employee or for the base employee class. The base employee class doesn't even really implement a print check function. It just outputs an error message.
And why does that happen again?
Why is there an error message in the employee function?
Yeah, for the print check.
Because you're not supposed to use the employee function to create any objects. It's only a prototype. So if you want to create an object, you'll use one of the child classes, one of the derived classes. In this case, either hourly employee or salaried employee.
So this base class shouldn't be like doing the operations or.
Yeah, the base class is just really to hold on to things that are common to all employees. So it knows how to, it's got the common variables, name, social security number, net pay, and it's got the common accessors and mutators for those functions. And then it has a prototype for the print check function, but if you try to use that print check function, it's going to tell you you're doing it wrong, because you need to write your own for the various types of employees you're going to use.
And if I'm not mistaken, as far as inheritance, like the social security number and all those, the derived classes are going to get those, right?
Correct. Yes. You'll have access to those without declaring them in your derived class. So if you look at the implementation for the derived class hourly employee, starting on page 819, display 15.5, basically we've declared the constructors for our new class, hourly employee. And And you'll notice that it actually calls the constructor for the underlying class by name. The employee constructor gets called.
The very first one.
So that automatically does everything it needs to do for the base class, and then anything extra we need to do, for example, set the wage rate and the hours, gets done for this class. And then on the next page you see the way they've implemented the print check for the hourly employee.
Yeah.
Okay, so you'll notice we called that constructor explicitly. That's because those constructors don't get inherited. They don't automatically do a construction for the new class. You have to write constructors for each derived class that you make. And
in that implementation, so the constructor for the derived class is actually calling the constructor for the parent class.
right, it's explicitly calling it, yeah. Anytime we want to use the private member variables from the base class, we don't have direct access to those. So, we can use the accessor dictator functions to get and set those values. Which brings us to page 826, the protected qualifier. So, since the derived class doesn't have direct access to the private member variables that are in the parent class, then there's a special way to get direct access to those, and that's with the protected qualifier. Some people think it's a bad idea to use protected, but it exists in the wild, so you should be familiar with it. Obviously, you can always use the accessor and mutator functions if you need to access those member variables. Protected allows you direct access to them. Page 830 has the implementation for salary employee. And then display 15.7 on page 831 is a demo program showing the use of derived classes. So they created an hourly employee object, Joe, set up the various variables and did a print check. Sample dialog on page 832 shows you how that would come out for an hourly employee. Okay, so I got Joe, an hourly employee. Boss is a salaried employee. And you can see the difference between those two types of objects. So, we said that we're redefining functions in the derived class that we want to be different. Redefining is distinct from overloading. We talked about overloading before, where you have the same function name but you have a different function signature. The signature is the name plus the type, the sequence of types in the parameter list. So for an overloaded function, they have different signatures. A redefined function would have the same signature. And of course you can do either one, but redefining is kind of has a special significance because you're calling the same function on two different objects. It's doing different things because they're different types of objects. And even though you're calling it with the exact same type of parameters or type of arguments. Sometimes you may need to refer to the original function in the parent class. Page 834 tells you how to do that if it's necessary. You'll see on page 834 the Sally H object is an hourly employee. If we wanted to use the employee print check function, then you would call it by saying Sally H dot employee scope resolution operator print check.
So it's taking the function from the base, the parent class, and using it with the object of the derived class.
Right. If you need to do that. It's probably fairly rare that you would need to do that, but it is possible. So we said constructors are not inherited. Destructors are effectively also not inherited. The copy constructor is not inherited. C++ creates a copy constructor for you, but it may not do what you want it to do. The assignment operator is not inherited. And it makes sense that all those things are not inherited because it's a new different class. It's got a different name than the parent class. If you think about it, it does make sense that those are not inherited. We're doing something specific, special to that particular new object. And they show you how to make those assignment operators, copy constructors, and destructors appropriately. Another feature of inheritance in object-oriented code is polymorphism. And polymorphism is basically associating multiple meanings to a single function name. They have something that's called a virtual function. And a virtual function in a sense is used before it's defined. And so their example is they've got a rectangle class and a circle class, and they say if we designed this project well, then the circle and rectangle would both be descendants of a parent class called figure. Okay, so if we want to draw a figure on the screen, well, obviously you need a different set of instructions to draw a circle than you need to draw a rectangle. But if the function belongs to those classes, we could call all of them draw, even though it's going to be doing something completely different. So, figure, we made the assumption, is going to have function that will apply to all figures. Like the center function that we discussed, the draw function that we talked about. Their center function, however, uses the draw function, and the draw function is different for every kind of figure. So if we just had a center function that was normal, that was inherited by all of the figures, rectangle, circle, triangle, whatever, then it would not work correctly because it doesn't know how to do draw. If we've defined a new triangle class from the figure and we haven't gone back and changed or updated the figure class, so the solution is that make a virtual function. And basically what that means is we don't know what this function is going to look like until it gets used, and then the object that it's getting used with will have some code in it that knows how to do that, and that's called late binding or dynamic binding. So Page 841 has a class called sale, and they've defined one of the function bill as a virtual function just by putting the virtual in front of the type for that function. Then on the next page, display 15.10 has a derived class called discount sale. Discount sale has the bill function in it. Not required to say virtual, but it's a good idea since we know that is defined as a virtual function. And we have a implementation for the discount sale bill. Tells us how to calculate the bill. And on page 843, display 15.11 shows you how to use the virtual function.
I don't think there's something looks like some double braces there. Is that something we should be concerned with?
Okay, where's that?
It's the derived class discount sale.
Oh,
Implementation.
yeah, basically they're just putting an empty body there
Oh, okay.
without saying this has been intentionally left blank or whatever.
Oh, so it's basically, it's just that bottom one is moved up. The second brace.
Yeah, they've just put it all in one line to save printing space in the book.
Okay, I see what you're doing.
So, if you want to use a virtual function, your function is going to be different in the derived class than in the base class. And you want it to be a virtual function, you add the keyword virtual, and that will make it automatically virtual in the derived class. It's added to the function declaration, and so therefore it becomes a virtual function, and the function definition itself is not basically figured out by the code until runtime. That does add some extra code in order to make that work at runtime, so it is a little bit less efficient than using a non-virtual function, and that's the only reason that you wouldn't just make all of your functions virtual. Then they have some more discussion of the typing in C and using virtual functions, and how you can use various objects interchangeably. They talk about the slicing problem. You know, whether a pet is a dog and a dog is a pet, or vice versa. It's not quite as simple when we're writing code. So they show you how to resolve that problem by making those functions virtual. That allows the code to actually run and create an object that starts off as a pet and basically becomes a dog when we put a dog data in it. And if we make our destructors virtual, that makes sure that we always call the appropriate destructor for the actual type of object that we've created. Now, that virtual stuff is a little confusing. I don't think you're required to make any virtual functions for your project for this week, but it's a good idea to know what they are and how they work a little bit, just in case you run across them. Any questions? Any questions about the assignment for this week? So you've already seen hourly employee and salaried employee. Your new class administrator is going to be derived from salaried employee. And basically you'll just enhance that in some of the same kind of ways that salaried employee was enhanced version employee and so forth.
So we just add all these member variables and the functions.
Right. And then make sure that your program exercises all of the functions. I want to see, you know, everything being used. If you've got, you know, 3 constructors, use all 3 of them. If you've got, you know, however many functions, use all of your functions. So I can see the various flavors of action that happen.
And we would need the whatever salary employee does also.
Yeah, you're gonna need employee, you're gonna need salaried employee, and then you're gonna make your own administrator that's derived from the 2. Any other questions?
No.
All right. Well, I guess we'll talk to you next week then.
And on the, well, actually on the one we're doing right now,
Yes?
I am kind of having some issues with that one.
Okay.